let me give you a concrete example of why it's important to know the vital details of your workload. Let's suppose that you want to run a large workload which is going to analyze 1 million small documents with a common program. And let's suppose each of these documents is on the order of a kilobyte. So each one of these is going to be consumed by a program, which is going to produce an output. So we're going to have lots of those. And now, before actually running a million tasks, you decide, let's do a little test and see how long each one takes. So we'll try one of these, and we discover that each one takes about 5 seconds. Now, 5 seconds isn't much time, but remember, you've got 1 million documents to produce, so we've got over 5 million seconds of compute time, so this is going to take quite a while. Now, the first thing that you might be tempted to do is to take each one of these tasks and submit it directly into your batch system. So make a little file for this, submit it. Make a little file for this, submit it. And so on and so forth until we have 1 million jobs in the batch system. Turns out this is not such a good idea. Let me write this down here so you don't forget. It's a bad idea. But it's not obvious why it's a bad idea. Let me explain why. When I take a single job and put it into a batch system, there's always going to be some queue waiting time. So if we look at what happens in the lifetime of a job here, it gets submitted. There's some waiting time. And then eventually it runs. And in this case, it runs for 5 seconds. And then finally, it's done. Now here's the problem. In most batch systems, this wait time is non-trivial. And I'm going to give you a rule of thumb. And that rule of thumb is that this wait time is about 30 seconds. Now, it's a rule of thumb. It's not a perfect prediction. Sometimes it's really fast. Sometimes it's really slow. But as a way of approximating, 30 seconds is a pretty good approximation, because the batch system isn't just going to run your task anywhere. It has to look at all the different options. It has to schedule with other users. It has to log things to disk. It's going to take time. And we've seen this number come up over and over and over again in a wide variety of batch systems. Now, what's going to happen then if it takes 30 seconds just to get your job started, and then it takes 5 seconds in order for it to actually run? Well, we're going to have some wait time and then some run time. And then that same machine is going to have to wait for a little while and then run another job. And then wait for a little while and then run another job. So if it takes 30 seconds to start a job, what's the efficiency of the cluster going to be? Well, what we're going to see is that for every 5 seconds of runtime, we have 35 seconds of real time. And that means the actual utilization of the cluster is going to be 14%. And that's terrible. That means the cluster is spending most of its time waiting around and scheduling jobs, and a relatively small fraction of time actually running jobs. Now, we can do a better job. Instead of sending each task as a single batch job, which results in a large wait time, what we can do is we can take a large number of tasks here and group them into a single batch job. So suppose we take 100 of these tasks and put them together into a single batch job. Now, what's going to happen? We still have to pay the wait time. Again, our rule of thumb is 30 seconds. But after we pay that wait time of 30 seconds, we're going to run one long job that consists of each of those individual tasks taking 5 seconds. And so this whole thing is going to take 500 seconds. And now we get much longer jobs relative to the waiting time that we're required to pay. How much better? Well, all we have to do is take our total runtime, it's 500 seconds, and divide by the wait time plus the runtime. And this is going to give us 94% utilization of the cluster. So as you can see, when you design a workload, you have to know some basic facts about the application, because if you were just to take a bunch of small tasks and throw them at the cluster, you get terrible utilization. By thinking a little bit about the orders of magnitude, we can get drastically better performance.